The overall goal of this procedure is to measure the conversion of hyperpolarized pyruvate to lactate by magnetic resonance imaging, or MRI, in a controlled phantom environment.
This method can help answer key questions in the hyperpolarized MRI field, such as the ability of a system to detect chemical conversion of pyruvate by magnetic resonance.
The main advantage of this technique is that chemical conversion of pyruvate proceeds similarly to metabolism in vivo, but is more controllable and repeatable than in living systems.
The implications of this technique extend towards diagnosis of cancer because the elevated conversion of pyruvate to lactate, common in most cancers, is simulated by the phantom environment. Though this method can provide insight into cancer, it can also be applied to other metabolic imaging, such as cardiac metabolism.
Generally, individuals new to this method may struggle because the time constraints inherent to hyperpolarized media are short. Visual demonstration of this method is critical as dissolution and injection steps are difficult to learn because they have to happen rapidly and must be performed precisely.
In a sample cup for a dynamic nuclear polarization, or DNP system, pipette 0.3 microliters of the gadoteridol solution and 13 milligrams of the pyruvic acid solution. Briefly stir this mixture in the sample cup with a pipette tip. Begin the sample insertion process by clicking the Insert Sample button on the DNP system console. On the sample wizard, select Normal Sample and click Next. Keeping the sample cup vertical, gently place the insertion rod over the top of the sample cup. When prompted, open the DNP system and insert the cup into the variable temperature insert using the insertion rod.